before going to the instruction set, it is mandatory for us to know the architecture part. So this is the overview of ARM architecture. If you look at the screen, look at the cursor. The ARM architecture starts from ARM 7, then ARM 9, then ARM 11, which is called as classical ARM processors. Then ARM Cortex series has come, where Cortex-A series were the application, which includes multimedia applications, wherever we have audio and video, which includes a smart TV, which includes a set-top box, which includes digital cameras, which includes mobile phones. They use ARM Cortex-A series, where multimedia applications are there. Wherever there is audio and video, Cortex-A series are being used. Cortex-R series are for application series, and Cortex-M for microcontroller. And our focus is to target much on Cortex-M4, which is much into embedded applications. Okay. And there are different versions we need to understand. There is version 4 for ARM 7 TDMI, then version 5. Version 4 and version 5 are the two versions before ARM Cortex. And version 6-M means for Cortex-M series, and version 6-A means Cortex-A series. As we see here, ARM V7A means Cortex-A series, ARM V7R means version 7 for real-time processor core, and V7M means Cortex-M4. So we are focusing much on Cortex-M4 in this presentation. So it uses ARM version 7-M means version 7 exclusively for Cortex-M series. It is the one we need to understand. With this understanding, we can go to the detail about the instruction set. So the reference for this particular instruction set is taken from the textbook called The Definitive Guide to ARM Cortex-M3 and Cortex-M4 Processors, written by Joseph Yu from the ARM Limited, Cambridge, UK. It is requested you all to refer this book, chapter 5 in this book, talking about the instruction set, and 5.6 gives a detailed description about the instruction set. Quickly to refresh, 5.6.1 talks about moving data within the processor. Moving the data within the processor means moving the data between registers. And 5.6.2 talks about memory access instructions. So as we all know, memory access with respect to RISC architecture is load store architecture. So load means registers are loaded from the memory. Store means the content of the registers are stored into memory. So processor can talk to the registers. Registers can talk to the memory, which you call it as load store architecture, which is used in ARM architecture. And multiple registers can be loaded and multiple registers can be stored by using multiple load and store. And there is a stack push and pop, stack pointer relative addressing, and load store with unprivileged access level, exclusive access. So 5.6.1 and 5.6.2 comes under the category of data transfer instructions. As we all know, ARM instructions are broadly classified into three: data transfer instruction, data processing instructions, and program flow control instructions. So 5.6.1 and 6.2 comes under data transfer instructions. 5.6.3 to 5.6.8 comes under data processing instructions, which includes arithmetic operations, logical operations, system rotate instruction, data conversion operations, bit field processing instructions, compare and test instructions. And 5.6.9, which is program flow control. So branches, functional calls, conditional branches, compare and branches, if then else instructions, and table branches comes under this category. So data transfer instructions, data processing instructions, and control flow instructions are the major classifications, which will be discussed in detail in this 5th chapter in this textbook. Along with that, there are ARM Cortex-M4 specific instructions like saturation operations, exception related operations, sleep mode related instructions, memory barrier instructions, and other instructions which are especially for Cortex series. Along with that, Cortex-M4 specific instructions in 5.7, which talks about enhanced DSP extension in Cortex-M4, single instruction multiple data and saturating instructions available, and multiply and accumulate instructions, and packing, unpacking, and floating point instructions are described in detail in this chapter. So in this book, chapter 5th, 5.6 talks about the instruction set clearly, which is mandatory for us to understand. Because of these instructions, we are able to do much wonders in our mobile phone, and the mobile phone is more efficient just because of these processors and these instruction set features are running behind the screen for us, that we need to understand. Okay, so quickly to start. So the design of the instruction tree is one of the most important parts of the processor's architecture. In ARM terminology, it is commonly referred to as instruction set architecture. All the ARM Cortex-M processors are based on Thumb-2 technology, which allows the mixture of 16-bit and 32-bit instructions to be used within one operating state. The evolution of ARM instruction set architecture is much more clearly visualized with diagrams. Here you can see this is the complete overview of the diagram as we have seen right now about the versions. Earlier, there was only ARM instructions which are of 32-bit. So, if ARM instruction after ARM processor is being introduced, which is 32-bit processor, and the people started developing application using ARM processor, means they've identified one drawback of memory constraint. Say for example, in 8051 microcontroller, if we write 10 instruction means it will by only 10 bytes. But if we take the ARM processor, the instructions are 32-bit instructions. So the same 10 instructions are used means 10 such instructions means 40 bytes. It will have base 40 bytes. So because one instruction 4 bytes, 10 such instruction 40 bytes. So the same application program using 8051 attack base 10 bytes, but 4 times the memory is larger in when we use ARM instruction. It was one of the drawback initially. So the ARM decided to reduce the instruction set size from 32-bit to 16-bit, and the size reduction is named as thumb instructions. So 32-bit instructions were shortened into 16-bit instruction, and they are called it as thumb instructions, where the memory issues has been reduced. Okay, so instead of 4 times, at least 2 times the memory, which is somewhat tolerable. Okay. So the ARM instructions 32-bit and ARM thumb instructions, which are of 16 bits, which is available from the version 4. The T denotes it is thumb instruction. For example, in an ARM 7 TDMI, what do you mean by TDMI? ARM 7 core, T denotes it is thumb instruction. So T means thumb, which is 16-bit instructions. So if your application is memory constrained application, we can use thumb instructions, which are 16-bit, which occupies only very less memory. So then again we'll go to the version 5. In this version 5, the same 16-bit thumb instructions was used, and here you can see ARM v5. T denotes thumb, and there is an E. E means extension. What do you mean by extension? DSP instructions are there. So as like multiplication, accumulation instructions, which is mandatory for our signal processing applications. Version 5 architecture has thumb instructions along with extension, which is available in ARM 9 core of processors. Then the instruction set architecture, that is ARM v6 version 6 architecture, uses the same 16-bit thumb instructions. Along with it, we have a floating point operations also, along with single instruction multiple data features in the ARM instruction set. So in these 3 versions, that is ARM 7, ARM 9 and ARM 11, so thumb was separate. And in the Cortex series, so thumb is merged with ARM instructions, so there is no separate, so both are same, so which is called as Thumb-2. So all the Cortex-M series uses Thumb-2 instructions, which is different from ARM 7, ARM 9 and ARM 11. So ARM 7, ARM 9 and ARM 11 uses thumb instructions which are of 16-bit. Here it uses Thumb-2 instructions which can be combined with 16-bit as well as 32-bit instructions as in one state. So whatever we are able to do with ARM instructions in 32-bit, that is near advanced single instruction multiple data, floating point operations, DSP, single instruction multiple data, all the features which we use it in ARM instructions can be done in the thumb instructions also, as we see here near advanced SAMD, floating point, DSP, SAMD. So what we do with 32-bit ARM instructions, the entire thing can be done with 16-bit as well as 32-bit thumb-2 instructions. There is no separation. What all things we can do it in 16-bit instruction, it is thumb-2. Here there is a limitation. DSP, SAMD cannot be done with thumb, and DSP cannot be done with thumb, and something like this. But thumb-2 can do DSP, floating point, as well as single instruction multiple data, which is a special feature with respect to ARM Cortex series, which is ARM version 7, as we see here very clearly. In this context, all the Cortex architectures are much special, and all the ARM Cortex instruction sets which has Thumb-2 technology, which is also much special. So that's why people are much focused towards ARM Cortex series in their applications. So this is the special feature which makes ARM much popular, especially ARM Cortex series of microprocessors much popular in most of the applications nowadays. So the same technique which is described in another way. So where you can see the top version 4, version 4 thumb, and version 5 thumb, and version 5 thumb extension, and version 6, version 7, and version 8 ARM versions. Where earlier ARM instruction set was there in version 4, there was no thumb instructions in version 4 as you see here. In the version 4 there was only ARM instruction set. Then in the version 4T, you see version 4T, there comes the thumb instructions. As you see here, look at the screen, look at the cursor. ARM7 TDMI thumb instruction set was introduced in version 4T of ARM instruction set. Then number of instructions are keep on increasing. The staircase kind of things means number of instructions are keep on increasing in every version. So next version 4 thumb, version 5 thumb has much more instructions, and version 5 thumb extension has enhanced DSP instructions, and version 6 has floating point instructions as well as single instruction multiple data instructions, and version 7 will have advanced single instruction multiple data and floating point operations, and finally version 8 has much more instructions, which is clear. So similarly, thumb instruction was introduced in version 4, and in version 5 much more thumb instructions was there. In version 5 thumb extension was there. In version 6 again Thumb-2 technology was introduced, and much more instructions was introduced in the Thumb-2 technology, and more or less in version 7 and version 8 we are able to see whatever we do with 32-bit, the entire thing we can do it 16-bit, if necessary 32-bit also. So Thumb-2 technology is currently used in version 7 and version 8. So as we see here, whatever we have discussed, now it is represented here clearly in the form of instruction set. As you see, general data processing instructions and simple input-output control instruction tasks, which was available in CORTEX-M0, CORTEX-M0 Plus, and CORTEX-M1, which we call it as ARM version 6 -M means ARM version 6 -M denotes it is CORTEX-M series. Then comes version 7 CORTEX-M series, which is M3. M0, M0 Plus, and M1 is V6M version. V7M versions will have CORTEX-M3, which has, along with general data processing instructions and input-output control instructions, we have advanced data processing instructions, hardware divide instructions, bit field manipulation instructions, multiply and accumulate instructions. Some more instructions was added, as you see here, in CORTEX-M3, which is ARM version 7. And ARM version 7 extended thing, which is CORTEX-M4, which is our core, where there are DSP instructions, which is single instruction multiple data. CORTEX-M4 with floating point unit will have much more floating point operations instructions are there. More the instructions, more the simplicity, complex applications can be done as simple as possible. So for example, the CORTEX-M4 DSP instructions are possible means, so all the signal processing applications can be done just like that in the single handheld devices. That means what we experience with the PC, the same thing we are experiencing with the mobile phone because of the special features in this architecture as well as in the instruction set, as for example. And there's another way of those instructions, right? So 16-bit instructions, which are our thumb instructions here in version 6, and CORTEX-M3 will have much more instructions, CORTEX-M4 will have much more instructions, and with floating point instructions will have much more instructions, as you see here. So this is overview. Then based on the functionality we are classifying, and then we are going to see one by one in detail. So based on the functionality, the instruction set of CORTEX-M processors are classified into various groups. In the first group, we are talking about moving the data within the processor, as discussed right now. Between the registers, if we are moving the data means, then moving the data between the registers within the processor means between registers and special register and the conventional registers. And the memory access instructions, which includes load store architecture. Then comes arithmetic operations, then logical operations, then shift and rotate operations, then extended and reverse ordering operations. Why extend and reverse ordering? Extend means even though it is a 32-bit processor, it should compute 8-bit and 16-bit data. So to compute 8-bit and 16-bit data, this extend operations will be very much useful. So for example, 8-bit data must be converted to 32-bit data, and 16-bit data must be converted to 32-bit data, and reverse ordering. Reverse ordering is mainly used for big Indian and little Indian, which we'll be discussing in detail, right? So moving data within the processor and memory access, which comes under data transfer instructions, this arithmetic operation, logical operation, shift and rotate instruction, and conversion operations, and bit field processing instructions. Up to this will come under data processing instructions, data transfer instructions, data processing instructions, and program flow control means branch control instructions. So branch, conditional execution, and function calls comes under program flow instructions. And the most important signal processing instructions like multiply and accumulate instructions, and divide instructions, and memory barrier instructions. Because of the memory protection unit in ARM Cortex-M4 series, there are memory barrier instructions are also available, and there are few exceptions, right? Exception related instructions and the sleep mode related instructions, and we have enhanced DSP instructions, right? Already there are DSP instructions like multiplication, accumulation instructions, MAC instructions. Then there are much more DSP instructions like single instruction multiple data operations, SIMD operations, and packing instructions, and fast multiply and MAC instructions, and saturation instructions, and floating point instructions for exclusively for signal processing was there. So this is the simple overview about instruction set architecture of ARM Cortex-M4 series. As a summary, in the following sessions we will be discussing everything in detail one by one.